Hello class, in this video we talk about section 2.3, Venn diagram. I recommend you carefully read my table note for this chapter after you finish section 2.3. In section 2.3, we are going to use the tool of a Venn diagram to visualize the relationships between sets. So here the definition for Venn diagram. Venn diagram is a rectangle box containing the universal set. All the subsets are represented with circles. What is a universal set? A universal set, symbolized by U, is a set that contains all the elements in discussion. This is a Venn diagram. And by the way, Venn diagram is named after John Venn. I think it was a little bit time of yours to read information about John Venn. Yeah, you can Wikipedia. He's the one introduced Venn diagram, very powerful tool. He's an English mathematician, logician, and philosopher. Okay, let's go back our note. Whenever you see a box, rectangular box, that is our universal set. The universal set contains all the elements, all the members being considered. In this box, we have two circles, and they represent two different sets, A and B. As you can see, A and B have no common elements. They do not overlap. When that happens, we say set A and set B are disjoint. Disjoint means do not overlap. In this Venn diagram, we also have two sets A and B. The circle of A completely fall within the circle of B. And that relationship, we actually mentioned this yesterday, that relationship represents a proper subset. When the circle A completely fall within the set B, we say A is a proper subset of B. All the elements of A are also elements of B. B has more elements than A. So in that case, we say A is a proper subset of B. And when A and B are equal, we can use this notation. We can use A equals B and draw the circle to represent the two sets as a Venn diagram overlapping in the box, in the universal set. In this Venn diagram, circle A and circle B overlap, and the dark region represents the dark region here. The dark region here contain the common elements of A and B. When A and B are overlapping, they do not disjoint. They are not disjoint. And when you see a notation, when you see a prime on the shoulder of capital letter A representing a set, yeah, like this one, A prime. A prime represents the complement set of set A. We can call A prime as the complement of A. A prime represents a set in which all the elements do not belong to A. A prime is not A. It includes all the elements in the universal set, but not elements in A. Venn diagram describes the shaded region as A prime. A is the circle. Then within the rectangular box, outside the circle, the blue region represents A prime, the complement of set A. Well, let's do some problem to reinforce the concept we have just learned, universal and complement. In this Venn diagram, we have two sets, A and B. So the first part, we need to find the universal set. In the universal set, we have element A, B, C, D, E, G, A, B, C, D, E, oh, F, G, sorry, F, G, right? Yeah, all the elements within the box, they are elements in the universal set. Set B, let's see what are the elements in set B. Set B is represented by the circle, right? This circle. And there are two elements in this circle, D and E. We use a comma in between the elements to separate those elements in the set. Part C, we need to find the set of elements in A but not B. We are looking for a set which contains all the elements in A but not in B. In A, we have A, B, C, D, but D is in B, so we cannot include the D. So only A, B, C. Which region represents the set of elements in A but not in B? The set is represented by region I. You see I? It's like a moon, right? Let me highlight it for you. This region. This region in Venn diagram represents the set of elements in A but not in B. Okay? In A but not in B. From the circle A, we cut off the part belong to B, and the rest of the region represents the set of elements in A but not in B. So it's represented by region 1. Part D, the set of elements in U that are not in B. Equals braces. We're looking for the elements in U but not in B. So we have A, B, C, F, G, right? From the universal set, we remove elements D and E because D and E belong to set B. The rest of the elements are in a set of elements in U that are not in B. So this actually is B prime, guys. We can write this as B prime. B prime. B prime is a notation that describes the set of elements in U that are not in B. Okay? Part E, the set of elements in both A and B. Common elements. What's the common region? The darker region is a common region, right? Yeah. It only has one element, D. It is represented by region 2. Okay, region 2 is the common part of A and B. Union. Union is a very important relationship between sets. And the notation for union is this right side up, capital U. And when we see this notation, A union B, we see a set. That is a one set, okay? Yeah, that is one set. A union B, that notation represents one set in which the elements either belong to A or belong to B or belong to both. And we can call A union B as A or B. So in set theory, we can translate union as or. Or here is an inclusive or. What does that mean? Inclusive. So do we have exclusive or? Yeah, we do. We have inclusive or. We have exclusive or. So let me give you some examples about the exclusive or. So let's say you go to a restaurant, and the waiter tells you that they have a specialty. If you order the specialty meal, and they would give you, they will give you salad or soup for free. They will give you something for free, salad or soup. So what do you think about the or here? Is it inclusive or exclusive? I believe he meant exclusive. You cannot get a both. All right. Another example. Let's say you are dating two boyfriends. Let's say you are dating two people, A and B. So you are going to marry A or B this year. So either you marry A, not marry B, or you marry B or not marry A. You cannot marry both, right? So exclusive or here is one or the other, not both. An inclusive or, on the other hand, means A or B or both. It's possible for A and B occur at the same time. To describe that, we can imagine in a bar, okay, on a wall, there's a big rectangular shape, a big rectangular box, and rectangular box, and you are throwing darts to the box. All right. So let's say the box is super large, so you will not miss. You will always throw on the wall the rectangular box, and in the box you have two circles A and B. And the boss of the bar says if you hit A or B, and you get a beer for free. So what if you hit this region? Your dart hits this region. Would you get a free beer? Of course, right? Yeah. So A or B means the whole region, this region. And this region has two parts. Let me color them differently. So this is A, only A. And this is only B. Right? Only B, not A. And this is A and B, both, right? Yeah. Only A or only B or both. Yeah. Either of the three cases occur. That means A or B occurs. A or B occurs. So in set theory, including in later chapter when we learn probability, or here is an inclusive or. Inclusive or means A or B or both. In a case A and B are disjoint, then the region represents A or B would be the together, right? Yeah, you just union the two regions together. Yeah, again, A union B represents a set whose elements belong to A or B. Or here is inclusive. Intersection. We translate intersection between two sets as AND. Notation-wise, you see a upside down U connect two sets. So when you see A intersection B, that means A and B. That is one set. That is the intersection of A and B. It represents a set whose elements belong to A and B. In other words, the set of A intersection B includes the common elements of A and B. Common elements of A and B. In Venn diagram, A and B can be represented by a common region, like this region, shaded region. That represents A and B, A intersection B. In case A and B are disjoint, this case, when A and B are disjoint, the A and B is empty, okay? In the case A and B are disjoint, A intersection B is empty. The intersection of A and B is empty because they do not have any elements in common. We talked about the empty set yesterday. All right? So that is concepts about union and intersection. Very basic and important. Union and intersection. Let's work on examples. I think the best way to understand, I'm trying to erase that. Let's see if I can erase that. Yes. Okay, so describe universal set U that includes all elements in a given set. We have A and B. If we include all the elements being considered, and we have Pepsi, Sprite, Coca-Cola, and 7-Up. Just put all of them together, and you have the universal set. Next question. Let U be the universal set, which contains elements A, B, C, D, E, F, G, H. And we also have 3 sets A, B, C in the universal set. And A, B, C are subset of the universal set, okay? Any sets would be a subset of the universal set. We need to find the following. First one, you need to understand the notation, right? This notation means what? The intersection of B and C. Or you can just call that notation as B and C. It includes all the common elements of B and C. So B and C, they have common elements, right? B is common, and that's it. And that's it, right? Only B is in common. Yeah, H is not, G is not. So that is B and C. Okay. Yeah, the second one, B prime union C. Yeah, let's not rush. Let's not rush. How about let's find the B prime first. As a component set of this compound set, B prime not exactly given, so we have to find the B prime first. B prime includes all the elements in U but not in B. B has BGH. BGH. So in a universal set, get rid of BGH. We have A, C, D, E, F. Yeah, A, C, D, E, F. And that is B prime. Yeah. We are looking for B prime or C. So we are looking for the union of B prime and C, right? So all the elements either in B prime or in C or in both. Let's see, we have A, we have B because B is in C. We have C, C is in common. We have D, D is common. We have E, E is common. We have F. A, B, C, D, E, F. And that is B prime union C. Next, we have the prime of A union B. So I would find A union B first, and then process the complement. Let's find A union B first. A has AGH, B has BGH. So together they have ABGH, right? ABGH. That is A union B. The complement of A union B includes all the elements in U, but not in A union B. Okay, A union B has A, so we get rid of A. Has B, we get rid of B. Has G, has H. So we get rid of those elements, and the rest of the elements have C, D, E, F, and that's the complement of A or B. Find A or B first. Yeah, don't rush. Find A or B first, and then find the complement of A or B. Simply just remove the elements in A or B from the universal set. The last one, we have A prime intersect C and then intersect B. Okay, so we are going to find the A prime first. A prime is the complement of A. It includes all the elements in U but not in A. A has AGH. AGH. So A prime has B, C, D, E, F. Yeah, B, C, D, F. So that is A prime. And we are going to take the intersection of A prime and C. A prime and C. C is right here. Yeah, what's the common elements of those two sets? We have B in common, we have C in common, we have D in common, E in common. Actually, they are the same, right? Yeah. Turns out A prime and C are equal. B, C, D, E, F. Okay. So their intersection would be the same set. And then A prime union intersect C and then intersect B. B is right here. Let me organize a little bit. Become messy. Oops. I'll keep B prime here. Let me erase this part. So we have A prime union C already. So now we are going to take the intersection of this set and this set, BGH. So what elements do they have in common? B is common. G is not. H is not. So B is the only element in common. So the result is just a set contains one element B, right? Yep. Okay, so use the Venn diagram to determine each set or cardinality. Set B from this Venn diagram is a set represented by this circle, right? Yeah. In this circle, as you can see, we have 1, 2, 3, 4, 4 elements. We have this delta notation. We have order 2, 6, 4. And that is set B. That is set B. Cardinality of B. Do you still remember the concept of a cardinality we went over yesterday? Cardinality of a set is the number of elements in the set. Let's count how many elements in. Oh, okay, actually, it's a B prime, right? Yeah. We have to find the B prime first. So be careful. With prime and without the prime is different. We are not looking for cardinality of B. We are looking for B prime. So we need to find the B prime first. So from universal set, we get rid of the elements in B. We would have a B prime. And it includes this pound sign, dollar sign, and the sequence 1, 0 and sequence 0, 1. Yep, 4 elements. So the cardinality of B prime is 4. A intersect B prime. We have A, let me write A here. A is a set containing the pound sign, dollar sign, and the delta sign. That is A. We are looking for the intersection of A and B prime. Intersection means and, right? So we are looking for the elements belong to both, the common elements. Pound sign is common. Dollar sign is common, and that's it. Another way to understand this set, this actually means A and not B. So this set would include elements in A but not in B. It actually represents this region in A but not in B. It has 2 elements. Next, we have one more part. Cardinality of U minus cardinality of A. Cardinality of A is 3. Cardinality of U is 8 because it has 8 distinct elements, right? 1, 2, 3, 4, 5, 6, 7, 8. So the cardinality of U minus cardinality of A would be 5. Next, use the formula for the cardinal number of the union of 2 sets to solve. And what is this formula? The formula says the cardinal number of A or B equals cardinal number of A plus cardinal number of B minus cardinal number of A and B. Why is that? Consider the region or the area. The area of this region is area of A plus area of B, but the overlapping part is counted twice, right? So we have to remove one of the repeating area. That gives us the area of this region equals the area of A plus area of B minus area of the common part. And the region, the area of the region actually can be corresponds to the number of elements in the region. And we can generalize that to cardinal number. Let me know, does that make sense? If not, please email me. All right? Just to think about the region, the area of the region. All right, so we are going to use this formula to answer the question. Set A contains 12 numbers and 18 letters. So how many elements in total? 30, right? Set B contains 14 numbers, 10 letters. So how many elements in total? 24. One number and 6 letters are common to both A and B. So that means the cardinal number of A and B is 7, right? One number and 6 letters are common to both A and B. Find the number of elements in set A or set B. So we are looking for cardinal number of A or B. And that is cardinal number of A plus cardinal number of B minus the cardinal number of A and B. Very straightforward. 30 plus 24, 54. 54 minus 7. 54 minus 7. 47, right? That gives us 17. Yeah, correct. Or 30 minus 7 is 23. 23 plus 24 is 47. A math tutor working with a small group of students asked each student when he or she had studied for class the previous weekend. Their responses are shown in the Venn diagram. This example gives you an example. How do you record the results of survey by using Venn diagram? It's a very efficient tool. As you can see, in the universal box, we have two circles. The circle on the right represents students, the set of students who studied on Sunday. The circle on the left represents the set of students who studied on Saturday, right? Use the Venn diagram to list the elements of each set in roster form. The set of students who studied Sunday. Look at the circle on the right. And we have Mike. We have Josh. We have Emily. We have Hannah. We have Ethan. 1, 2, 3, 4, 5. Yeah, those 5 people are in circle. The circle on the right representing the set of students who studied on Sunday. The set of students who studied on Saturday and Sunday. The overlapping part, right? The darker region. Who studied on both Sunday and Saturday? Mike and Josh. In this dark blue region. The set of students who studied Sunday and not Saturday. Which region represents Sunday but not Saturday? Sunday. The yellow is, yeah, I'm trying to use the yellow here. Yeah, this yellow region represents the set of elements or students studied on Sunday but not Saturday, right? And we have 3 students there. They're Emily, Hannah, and Ethan. The last one, the set of students surveyed by the math tutor. That set refers to the universal set. All the students in a box. Okay? Yeah, I'm gonna write it right here. And it has Ashley, Mike, Josh, Emily, Hannah, Ethan, and Jacob. Don't forget Jacob, okay? Yeah, what happened to Jacob? How do you understand his response to the survey? He didn't study on either days, right? He does not study on weekend. So 1, 2, 3, 4, 5, 6, 7. 7 students received the survey, responded to the survey. And that's the last one. Yeah. So as I said, the purpose of the videos, class videos, are to guide you through the basic concepts. Basic concepts. Those are good examples. Once you understand those concepts, then you are ready to work on your homework. Homework is very important because the questions you're gonna see in quizzes and the questions you're gonna see in the tests are from the same pool, okay, from the same question bank. So really, if you make effort, it's not difficult to pass or get a good score from the class, but you do need to make efforts. If you need any help, please feel free to email me. I'll see you next time.